Alright guys, this is the review for the retest of systems in free variables. You want to go ahead and answer the did you watch this video and put down the time you started and the time you finished watching the video. The first question on this review is determine whether 325 is a solution to this system right here. And the way that we determine whether this is a solution to the system right here is that we plug it into each equation and see if it works. If it works in the equation, then we need to check all three. As soon as you find an equation that it does not work in, you can stop. So this is, remember, this is x, this is y, and this is z. So if we plug it into the first equation, that's 3 plus 2 times 4, 4 times 2, right? Here's the 4. Minus 2 times 5 is equal to 1, and that is 3 plus 8 minus 10 is equal to 1. That's 11 minus 10, and that is equal to 1, so it checks out in that equation. We need to test the second equation, so that would be 4 times 3 minus 3 times 2 plus 5, y'all will have to pardon my extra parentheses, is equal to 11. So this is 12 minus 6 plus 5 is equal to 11, and that's 6 plus 5 is equal to 11. Again, that is true. 6 plus 5 is 11. It checks out in that equation. And so we're going to check this last equation right here. So 5 times 3 minus 3 times 2 plus 5 is equal to 14. 5 times 3 is 15. 3 times 2 is 6 plus 5 is equal to 14. 15 minus 6 is 9, and 9 plus 5 is 14, so it checks out. So this solution worked in each equation. I checked it here, here, and here, and each time I got a true statement, and so the answer is yes. This ordered triple is a solution to this system, and that's because I got a true statement here, a true statement here, and a true statement here. If all of them are true, the answer is yes. If any of them are false, the answer is no. All right, we're going to solve these two systems of equations algebraically, and so that just means using algebra, not the calculator, and not guess and check. All right, and so I'm going to use elimination, and I'm going to use these two equations. I'm going to eliminate z. So I'm going to rewrite them. 3x plus 3y plus z is equal to 1. 2x minus 3y plus z is equal to 2. And do you know what, guys? I was going to eliminate z, but now that I'm looking at these equations right here, I think I'll eliminate y, because it will just disappear on its own for me without me having to do anything. So we're going to eliminate y here. And I did that because this is a positive 3y and this is a negative 3y, so I can eliminate it very easily. So this is 5x plus 0y plus 2z is equal to 3. And that's just 5x plus 2z is equal to 3. So I have one two-variable system. Now, I eliminated y here, which means I'm going to have to eliminate y in my second set. And so I'm going to go ahead and use these two equations, and I'm going to eliminate y in these two equations as well. So I'm going to rewrite the equations. So 2x minus 3y plus z is equal to 2. And x plus y plus z is equal to 3. If I want to eliminate y, I've got a negative 3y here. I've got to have a positive 3y here. And so I'm going to multiply this entire equation by 3. So I'm going to rewrite the system. So it's 2x minus 3y plus z is equal to 2. And I'm multiplying this entire equation by 3. So this is 3x plus 3y plus 3z is equal to 9. And now I've got what I say are equal but opposite, which, you know, is not really a math thing, but I've got 3 and one's negative, one's positive. So equal but opposite y's. And that means when I add these two equations together, the y's will cancel out. And I get 5x plus 0y plus 4z is equal to 11. And so that's just 5x plus 4z is equal to 11. And so now I have two equations that have an x and a z. And so I'm going to set those two equations up and look at them and see what I want to eliminate. So here's the 5x plus 2z, and here's 5x plus 4z is equal to 11. I have 5x in both, so I'm going to eliminate the 5x, but in order for me to do that, I need to make one of them negative. I'm going to make the top negative because it has fewer z's, but it really doesn't matter. We'll multiply by -1, so I get negative 5x minus 2z is equal to negative 3. And then 5x plus 4z is equal to 11. If I add these two together, I get 0x plus 2z is equal to 8, which is just 2z is equal to 8. And I can solve for z at this point by dividing by 2, and I get z is equal to 4. Now that I have z, I can use that to find x, and I can use one of these two equations. It doesn't matter which one. I'll go ahead and use this one. So the 5x plus 4z is equal to 11. We're going to plug that 4 in for the z. So this is 5x plus 4 times 4 is equal to 11. So 5x plus 16 is equal to 11. Subtract the 16, and we get 5x is equal to negative 5. Divide by 5, and what you get is x is equal to negative 1. Negative 5 divided by 5 is negative 1. That is my second variable. So now I have z and x. And what I can do is I can go from there, having z and x, and I can plug it into one of these three equations to find y. I'm choosing the last equation because y is alone in that equation. And so I've got that x plus y plus z is equal to 3. And I know that x is negative 1 and z is 4. This is negative 1 plus y plus 4 is equal to 3. And negative 1 and 4 combine to make 3. So this is y plus 3 is equal to 3. Subtract 3 from both sides, and you get y is equal to 0, guys. Y is equal to 0. And so our solution to this system right here, looking for a place to write it, is negative 1, 0, 4. Please be careful with your signs, guys. On the test, I had a lot of people get the first solution right and then forget the sign when they were plugging it into the other solutions. So like if you had negative 1 and you went to find y, you'd put a positive 1. Don't do that, okay? Just please be careful about your signs. Also be careful about your adding and subtracting and dividing by negative numbers and things. Just be careful, because being off by a sign can mean that your other two answers are completely wrong. And it's using elimination as well. And when I look at this system, I see that I've got an alone negative z here, and that this is a 3z and this is a 2z. And that is something that I can very easily use to eliminate z. So I'm going to pick two equations. I'll pick the first and the last first. I'm going to rewrite those down here so that it's easy for me to see the two equations next to each other. Okay. In order for the z's to cancel out, I need to multiply this equation by 2. And so I'm going to do that. So I get 4x minus 5y plus 2z is equal to 2. And 6x minus 12y minus 2z is equal to negative 8. And when I add these two equations together, what I get is 10x minus 17y plus 0z is equal to negative 6, which is 10x minus 17y is equal to negative 6. I need to cancel out the z's from a second set, so I'm going to use the second and third equations. So this is negative 2x plus 7y plus 3z is equal to 6, and 3x minus 6y minus z is equal to negative 4. I need to multiply the second equation by 3 in order to make this a negative 3z, which will cancel out. So I've got negative 2x plus 7y plus 3z is equal to 6, and 9x minus 18y minus 3z is equal to negative 12. When we add those two together, we get 7x minus 11y plus 0z is equal to negative 6, which is just 7x minus 11y is equal to negative 6. What I do is I take these two equations and I write them with each other, right? I make a third system. So 10x minus 17y is equal to negative 6, and 7x minus 11y is equal to negative 6. I'm going to eliminate the x's just because I'd rather multiply at least one of them by 10. That's easier than doing 11 and 17. So I need to multiply the top equation by, we'll do negative 7, and the bottom equation by positive 10. And that's going to make this one a negative 70x, and this will make this one a positive 70x. So it's negative 70x plus, and that is 119y is equal to 42. And this is 70x minus 110y is equal to negative 60. Add those two together, the x's cancel out, and so we get plus 9y is equal to negative 18. So just 9y is equal to negative 18. If you divide both sides by 9, you get y is equal to negative 2. That's a nice pretty number. In order to find x, I'm going to plug that y equals negative 2 into one of these two equations. I'm going to use this one. So 7x minus 11y is equal to negative 6. Plug the negative 2 in for y. So 7x minus 11 times negative 2 is equal to negative 6. 7x plus 22 is equal to negative 6. Subtract the 22. And we get 7x is equal to negative 28. Divide by 7. X is equal to negative 4. And we can now find z. I'm going to use this space way up here to find z, running out of room. I'm going to use the last equation because I won't have to divide by a 2 or a 3. I can just divide by negative 1. So remember that x is negative 4 and y is negative 2. And so we got 3x minus 6y minus z is equal to negative 4. And that's 3 times negative 4 minus 6 times negative 2 minus z is equal to negative 4. That's negative 12 plus 12 minus z is equal to negative 4. Those cancel out and are 0. And so we get negative z is equal to negative 4. Divide both sides by negative 1. And you get z is equal to, the two negatives make it positive, so positive 4. And so the solution to this system is negative 4, negative 2, positive 4.